Hey everyone, today we're going to learn about angles and standard position, which is the first lesson in our unit that's going to be on Unit Circle. So there are our objectives. Feel free to pause and read through those on your own. So let's talk about some basic vocabulary here. So an angle is said to be in standard, well, it would help if I, it's on pen. There we go. In standard position when the initial, sorry that things keep moving, but that should say initial side is placed on the positive x-axis and the vertex is at the origin. So vertex right here, initial side on that positive side of the x-axis. The side that is rotating is called the terminal side. So this is the terminal side. Right, there's our angle. Okay, and then the directed distance you rotate the terminal side is known as the terminal distance. Terminal distance. And it's denoted by a T, or we use the Greek letter theta. And theta looks like a little circle with a horizontal line through the center. So T or theta. Okay, so an angle is positive if the terminal side, and positive being t is greater than 0. An angle is positive if the terminal side is rotated counterclockwise. So think back to your geometry days when you talked about rotation. All right, so if you're going counterclockwise, that's against the clock. All right, an angle is negative, or t is less than 0, if the terminal side is rotated clockwise. All right, so here's some examples for you to look at. I drew in an XY axis for each of mine. So if I have 195 degrees, remember each quadrant is just 90 degrees. So 90, 180, and then a little bit further to get to 195. Okay, there is my angle, and I am in quadrant 3. -76, so we're rotating clockwise, and it's not quite 90, so we're going to end up in the 4th quadrant. Now 500 degrees, remember a full circle is 360, and then we got 450, and then 50 more degrees, so somewhere in there in the 2nd quadrant. And then -270. So 90, 180, -270. We're not in a quadrant. We are actually on an axis. And when this happens, we have a quadrantal angle. All right, so two angles in standard position that share the same terminal side are called coterminal. They don't need to have the same measure to be coterminal. So to find the positive coterminal angle, we're going to take that terminal distance and we're going to add 360 degrees if we're in degree mode, or add 2 pi if we're in radian form. To find the negative coterminal angle, we're going to do the opposite. We're going to subtract it. So here's some examples of some coterminal angles. Notice your alpha represents your positive distance and your beta is your negative distance, and they have that same terminal side. And there's another example of a positive, actually a positive and a positive. All right, so let's do some practice. So I have 100 degrees, so I'm going to add 360 to that. So 100 plus 360 gets me 460 degrees. All right, and then 100 minus 360 gets me negative 260 degrees. Okay. Now, 520 is bigger than 360, so I could actually subtract 360 and still get a positive coterminal, or I could add 360 if I like that better, it's fine. So 520 plus 360 is 880 degrees. Now, if I subtract 360, right away, notice that I'll get 160. So there's another example of another positive coterminal. All right, but I want to get a negative, so I have to subtract again to get my negative. So negative 200. All right, negative 75, I'm going to add 360, and that's going to get me 285. And I'm going to subtract 360, and that's going to get me negative 435. All right, and then negative 423, notice that when I add 360, it's still negative. So negative 63 degrees could actually be my negative, okay? And then I can add 360 one more time because I have to get to positive, and that will be 297. Okay, so now let's talk about reference angles. So for an angle in standard position, the reference angle is the positive acute angle measured from the terminal side to the nearest x-axis. And we actually talked about reference angles in our last unit a little bit with triangles, right? So 120 degrees, so 90 and then 30 more, gets us here. So there's my angle. So my reference angle is this acute angle to my nearest x-axis. So it's asking me what that is. Well, this whole distance, right, is 180. So we're just going to take 120 away from 180 to get 60 degrees. Our next angle is 370 degrees. So that's a full circle and then 10 degrees more. Okay, so I already gave you our answer. All right, so what's this angle measurement, this positive acute angle? Well, you would do 370 minus 360 and you get 10 degrees. Okay, negative 210, so we go negative 90, negative 180, and then we go a little bit further to get to that negative 210. All right, so what is that little bit further that we went? Well, we're gonna, if we pretended that instead of negative 210, it was positive 210 and just subtracted 180 from that, that would leave us with 30 degrees. Okay, and then our last one, negative 45, so we go right here. There's our negative 45 degree angle. So what's this? But as a positive acute angle, it's just 45 degrees. So now let's talk about the unit circle. What is the unit circle? Well, it's based off of the knowledge that we learned in our unit on conics. Remember, the equation of a circle is normally x minus h squared plus y minus k squared equals r squared. Our unit circle, okay, this is the equation for it. Notice that there's no h or k, meaning that the h and k are actually both 0, 0. So the circle is centered at the origin and the radius has a length of 1. We're going to use it to find some special trig ratios and aid when we graph trig functions. All right, and the terminal point the point where the terminal side lands on a unit circle is called the terminal point. Okay, so here we go. We've got our radius length 1. We've got another radius length 1 and theta right there, that distance, and we're centered at the origin. Okay, so what is a radian? A radian is just a unit of angle measure, all right, and it's the length of one radius unit wrapped around the circle. Okay, and we can convert from radians to degrees and degrees to radians. We're going to learn that actually in our next lesson. So there's my radius, and there's that length right there, and there's theta. All right, so we're going to talk about some families, and these are going to be really important for you to memorize, okay? So think back to your geometry days. The circumference of a circle is 2 pi r. But in our unit circle, the radius is 1. So if I replace my r with a 1, you'll notice that the circumference ends up being 2 pi. So that's the distance around my circle. So if I break that into 8 parts, okay, so 2 pi divided by 8, I end up getting pi over 4. So this is my pi over 4 family. We're going to draw it here, okay? So if we wanted to break up the circle into 8 parts, we would end up cutting each of the quarters into halves, or half of that quarter, okay? So now we're just going to count. So we got pi over 4. This would be 2 pi over 4, but that reduces, which, yes, we're going to do lots of reducing, to pi over 2. Then we've got 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then 8 pi over 4. Sorry, I should have started at 0. And then when we go full circle, it's 8 pi over 4, which is the same thing as 2 pi, so full circle. So here's some practice problems. We just want to sketch our angles and figure out what quadrant they're in. So 5 pi over 4, that's 1, 2, 3, 4, 5. So there's my angle. It's in quadrant 3. Negative 3 pi over 4, so go in that clockwise direction. 1, 2, 3. It's also in the third quadrant. 11 pi over 4. So remember, one full circle is going to be 8 pi over 4. So then 9, 10, 11. Right there. Okay, that's in quadrant 2. And then negative 9 pi over 4. So one full circle, right, is 8. And then one more gets us to be right there. So one full circle. Okay, and 11 pi over 4. Really, I should have done that. So this is in quadrant 4. Okay, then we can also find our coterminal angles, positive and negative. So remember, this time though, we're in radian form. So we're going to add or subtract 2 pi. Since we're dealing with pi over 4 though, we only want to add fractions that are over 4. So to change from 2 pi over 1 to something over 4, that something's going to be 8 pi over 4. So if I add 8 pi over 4, I get 9 pi over 4 for my positive coterminal. And if I subtract 8 pi over 4, I get negative 7 pi over 4 for my negative coterminal. For the next one, when I add 8 pi over 4 to negative 11 pi over 4, I actually get negative 3 pi over 4, which is still negative. So that's my negative coterminal. And then I can add 8 pi over 4 one more time to get 5 pi over 4. All right, with 17 pi over 4, since I already know that that's way positive, I'm just going to start by subtracting. And notice I get 9 pi over 4, which is positive. There's a positive coterminal. I can subtract again and get another positive coterminal of pi over 4. And then I can subtract one more time and get negative 7 pi over 4. And then for my last one, I'm going to add 8 pi over 4. And get 3 pi over 4. And then I'm going to subtract 8 pi over 4 and get negative 13 pi over 4. Okay, so the other two families come when we separate our circle into 12 spaces. All right, so take that 2 pi and we're going to divide it by 12. This reduces to pi over 6. So this is our pi over 6 and something family, and we're going to fill in that something in just a moment. All right. So if we want to cut our circle into 12 pieces, what's going to happen is each of our little quadrants are going to be broken up into 3 pieces, all of equal length. Okay, so there's our picture, the best that I can draw right now. And then we've got pi over 6, and then, 0, pi over 6, then it'd be 2 pi over 6, but that reduces to pi over 3. Okay, so this is also the pi over 3 family as well. Then we get 3 pi over 6, but that's just pi over 2. Then we've got 4 pi over 6, but that reduces to 2 pi over 3. Then we've got 5 pi over 6, 6 pi over 6, which is just pi. Sorry that keeps moving. 7 pi over 6 is our next one. Then 8 pi over 6, which is 4 pi over 3. And then we've got 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6, and then we're back to the beginning, 12 pi over 6, which is just 2 pi. And then we're going to finish it off with some examples. So if we want to sketch, we want to identify the quadrant. Okay, so these are our pi over 6s. So 1, 2, 3, 4, 5. There's my angle. We are in quadrant 2. All right, 4 pi over 3. If you don't like that, you can change it to over 6 by just multiplying by 2. So it's really 8 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8. So it'll be right there. Third quadrant. All right, so negative 7 pi over 6. Make sure you go in that clockwise direction. So 1, 2, 3, 4, 5, 6, and 7. So there is, okay, that one. That's 2. And then negative 11 pi over 3, I would again change it to 6s. Remember that every time around is 12 units. So we go 12 around, and then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we go all the way to there. Okay, I think I actually went one too far. I apologize. Let me. So we go 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There's 22. Sorry about that. All right, so we end up in the first quadrant. All right, and now let's get those positive and negative coterminals. So again, we're adding 2 pi, but we're dealing with out of over 3 or over 6. So when you're dealing with over 3, you want to add 6 pi over 3 because that's the same as 2 pi. When you're dealing with over 6, you want to add 12 pi over 6 because that's the same thing as 2 pi. So with 14 pi over 3, that's already pretty positive. You could automatically subtract if you wanted to. And that's going to get you 8 pi over 3, which is a positive coterminal. And you can subtract again, and you're going to get 2 pi over 3, which is another positive coterminal. And then you're going to have to subtract one more time to get negative 4 pi over 3 for your negative coterminal. For your next one, you're going to add 12 pi over 6 to get 19 pi over 6, and you're going to subtract 12 pi over 6 to get negative 5 pi over 6. For the next one, you're going to add 6 pi over 3 to get 5 pi over 3, and then you're going to subtract 6 pi over 3 to get negative 7 pi over 3. And then you're going to add 12 pi over 6 to get negative 3 pi over 6, which is still negative, so there's a negative coterminal for you. I reduced it to negative pi over 2. And then you're going to add one more time to get 9 pi over 6, which reduces to 3 pi over 2. And those are the basics. Make sure to ask any questions that you have in class.